Chapter 6, focusing on Section 6.1, Simplifying Rational Expressions. We'll first begin with the definition of a rational expression. It is a polynomial divided by another polynomial. So on the top, 2x minus 4 is our first polynomial. That is being divided by our second polynomial, x plus 5. The restriction for this is the denominator, or the bottom section here, cannot be equal to 0. So in this case, the only number I could add to 5 that would make this equal to 0 would be negative 5. Negative 5 plus positive 5 equals 0. And just to check that, I could say what number plus 5 equals 0. And then I could solve for x by subtracting 5 from both sides. And that would give me x equals negative 5. So x cannot be equal to negative 5 because the denominator can't equal 0. So some basic rules of fractions, since we'll be working with rational expressions, which are fractions, right? We have a top number divided by a bottom number. For any rational expression, a over b, and any polynomial, a, b, and c, where b is not equal to 0 and c is not equal to 0, a times c divided by b times c is the same as a divided by b. And what this means is if I'm multiplying the top number by the same number I'm multiplying in the denominator, those end up canceling out because they're the same value. So I'm simply, like, if this was multiplied by 3 and this was also multiplied by 3, it cancels out because 3 divided by 3 is equal to 1, or 3 over 3 equals 1. So it's the same as multiplying by 1. You would get the same, you would end up with the same value when you simplify. Or reduce is another word for simplify. So if we're asked to simplify or reduce 21 over 35, we're looking for a greatest common factor between 21 and 35, and then we want to rewrite each of these numbers as the product of those factors. So, for example, 21 and 35 both have a greatest common factor of 7. So if I would want to rewrite both of these, I would rewrite 21 as 3 times 7, 35 is 5 times 7, cancel out the 7's, and I've reduced this fraction to 3/5. Now let's look at it as a polynomial. So here where we have addition in the top and addition in the denominator, the numerator is the mathematical term for a top number of a fraction. So we want to find a common factor or grouping of variables and numbers in a polynomial that we can simplify by crossing out both from the top and the bottom here. So if we factor the top, the numerator here, both numbers have a factor of 5. 5 can be divided out of both numbers. So if I divide a 5 out of 5x, I'd be left with x, and 10 divided by 5 is 2. So that's how we're left with x plus 2. The denominator was already x plus 2, so because these are the same, they cancel out. That's our constant, and we're left with 5 as our final simplified solution. Here's another example. In this case, we are not only factoring the numerator, but we're also factoring the denominator. So this is where we're using what we learned from the last chapter to help simplify these radical expressions. So in the denominator, I noticed that this is the same as a squared minus b squared, which can simplify to a plus b, a minus b. A being our x value, and b being the square root of 4, which is 2. So that's where we get x plus 2, x minus 2 in the denominator. And in the top, in the numerator, I'm looking for, there's no coefficient here, so I can look for two numbers that multiply to equal 14, positive, but add to equal positive 9, so I know that it's 2 pluses. 7 times 2 is 14, and 7 plus 2 is 9. So those are my two factors, 7 and 2. And because these are the same it would equal 1, so those cancel out, and I'm left with x plus 7 in the numerator and x minus 2 in the denominator. Okay. So again, another one where we need to factor both the numerator and the denominator. The numerator, we can factor out an x from each term. And if we do that, we're left with x squared minus 3x minus 40. So we're taking out one of those x's from each term. And in the denominator, so far it stayed the same. So what can we do next? Well, looking at our denominator, we're looking for two numbers that multiply to equal 25 that also add to equal 10. And so that would be 5. 5 times 5 is 25. 5 plus 5 is 10. So there's our, they're both positive. X plus 5, x plus 5. And in the numerator, we're factoring the numerator even more. So we've already factored out that x, but now that we don't have x cubed, we don't have, a trinomial here, we're looking at, an x to the third power here, not a trinomial. We do have 3 terms. We're looking at what can multiply to equal negative 40. So I'm looking for a positive and a negative number that also adds to equal negative 3. And 8 times 5 is 40, and negative 8 plus 5 equals negative 3. So those would be my 2 terms here. So now the only ones that are the same that we could cancel out that would equal to 1 is x plus 5 divided by x plus 5. And then our most simplified form is x times the quantity x minus 8 in the numerator divided by or over x plus 5 in the denominator. Okay, we'll go through another example here. We're asked to simplify. So first, we can look and see that 6 and 8 both have a common factor of 2, so we'll take that 2 out. And in the denominator, we'll leave it as is for now. And then the next thing we want to look for is, are these the same? And yes, they are. It's just that they're written reverse. The negative 4 is written seconds in the denominator, and it's written in the first term in the numerator. But these two are the same. If I were to rewrite them, they would both say I have a negative 4x and a positive 3, so those can cancel, and we're left with a final answer of negative 2. Simplifying again, using our factoring that we've learned from our last chapter. So in the denominator, I noticed that 16 is a number that is a perfect square. So this is a squared minus b squared, so that would be 4 plus x and 4 minus x. And in the numerator, we can factor the numerator into x minus 4 and 2x minus 3. So this is where we're looking for factors of 2. It would be 2 times 1. So that's why there's this 1x here. And negative 4 times negative 3 equals positive 12. And then we can check our center term by using our FOIL method, but just going with the outside factors and the inside factors, because those are the ones that would multiply to give us a value of with an x in it, and that's what our center value has. So we can do, negative 3x and negative 8x, and that would add to equal negative 11. So those two numbers would work. So that's where we're using the factors from 12 to see which ones would work that would FOIL out to equal negative 11 as our center term, and 3 and 4 are those numbers. So once we factor those out, we can find out that, which terms are the same, which terms would be, can we cross out from our expression here. And I noticed that the x minus 4 and the 4 minus x are so similar. If we just multiplied or took out the negative or multiplied, by negative 1 here, we would be changing the sign in front of the number. So now this would become a negative 4 and this would become a positive x. And if I do that, then these two are the same and I can cancel them out. And I'm left with negative 1 in the denominator, so 4 plus x. and in the numerator 2x minus 3. Now I do want to distribute this back in to simplify it and get rid of any parentheses that I can, and so to do that we would multiply by the whole value by -1, and so we can just put that negative sign out in front of the expression here. And the last case is a final example of simplifying radical expressions. So in the numerator, we can look and see what can we do to break apart our expression in the top here. And then we'd ask ourselves also in the denominator, what can we do to break apart our expression here. Now, this is that in the form of a squared minus b squared, both 36 and 49 are perfect squares. 6 times 6 equals 36, and 7 times 7 equals 49. So this is a case where we do have a coefficient in front of each variable. So that would be a plus b, a minus b, but we do have those numbers in front of it. So 6a plus 7b, 6a minus 7b. So that explains how we can factor the denominator here. And then in the numerator, we're looking at 6a squared plus ab minus b squared. So this is a squared plus 2ab minus b squared, which is the same as saying a plus b, a minus b, and so we can rewrite our expression as 6a plus 7b times a minus b. And what's the same is the 6a plus 7b, and that can cancel out, and we're left with what we see here as our final solution.